So welcome to the second part of our discussion about soil compaction. So in this video, we will be discussing the specifications, the field control and measurement of in-situ density, the CBR test, and as well as some example problems for the previous topics under this chapter. So for the specifications of soil compaction, we have the relative compaction, which is denoted by R and is usually presented in percent. So that is the ratio of the dry unit weight in the field all over the maximum dry unit weight. So the numerator, or the dry unit weight in the field, is determined by the field density tests. So that can be the sand cone method, the rubber balloon method, or the nuclear method. So, however, for the denominator, which is the maximum dry unit weight, that is determined in the laboratory using the standard Proctor test or the modified Proctor test. So also we have the relative density d sub r, so you can get the relative density d sub r using this equation, and also we can denote the ratio of the minimum dry unit weight to the maximum dry unit weight as R sub O. So let us now establish the relationship between the relative compaction R, the relative density d sub R, and the R sub O. So from this equation, we can write that the minimum unit weight, the minimum dry unit weight is equal to R sub O times the maximum dry unit weight, and as well as the field dry unit weight. So this is equal to R times gamma D max. And we can substitute these two equations to this one. So we have d sub R is equal to R gamma D max minus R sub O gamma D max all over gamma D max minus R sub O gamma D max times the maximum, which is D max all over R gamma D maximum. Can cancel this. So you can write R d sub R is equal to R minus R sub O all over 1 minus R sub O. And then let us isolate the relative compaction, so R. So simplifying, so minus R times dr. So this is equal to R minus R sub O. And now we can write R, or the relative compaction R, as R sub O all over 1 minus D sub R times 1 minus RO. So, we can also express the relative density in terms of the void ratio. So, that is um, we have the void ratio E for the field, and then at the minimum dry unit weight, the void ratio is at its maximum, and then similarly for the maximum dry unit weight, the void ratio is in its minimum. So remembering that the formula for the dry unit weight, so we have the specific gravity times the unit weight of water all over 1 plus E. So we can substitute D sub R or the relative density. So G 1 plus E minus D sub S. So since this is the minimum dry unit weight, we have to write E as the maximum void ratio. And then so since this is the maximum dry unit weight, our void ratio E should be in minimum. So minimum all over water all over 1 plus E. And then cancel. Yeah. And then, so this is equal to 1 plus E max minus 1 minus E all over 1 plus E times 1 plus E max all over 1 plus E max minus 1 minus E min all over 1 plus E min times 1 plus E max, and you can cancel this one, and then we have 1 plus E all over 1 plus E min. So you can cancel this also. And then now we can simplify. So the relative density, so it's also equal to E max minus E all over E max minus E minimum. So, as I have said earlier, um, there there are three methods in where you can determine the unit weight or the compaction of the soil in the field, or the in-situ density. So first is the sand cone method, then the rubber balloon method, and lastly is the nuclear method. So, this is the setup for the sand cone method. We have the jar, which is filled with a sand. So, the the specific gravity of the sand is known. And then at the bottom of the jar, we have the valve to control the flow of the sand. And then we have the cone at the bottom, and then the metal plate at the base. So for the compacted soil, a hole is dug before placing this device, and then the valve can be opened so that the sand inside the jar can fill the hole. So in the sand cone method, first you have to determine the combined weight of the jar, the cone, and the sand filling the jar. So that will be your W sub 1. So next is you have to weigh the moist soil excavated from the hole. So, and then third is to calculate the dry weight of the excavated soil. So, balik lang tayo dun sa formula from the chapter 2. So, the dry weight can be calculated by the wet weight all over 1 plus the moisture content. And then for the W sub 4, this is the combined weight of the jar, the cone, and the remaining sand in the jar. So you have to weigh this after allowing the sand to fill the hole and the cone. And then fifth is to weigh the sand to fill the hole and the cone. So that is W sub 5. That is equal to W sub 1 minus W sub 4. And then now you can calculate the volume of the excavated hole. So that is the weight of the sand to fill the hole and the cone minus the weight of the sand needed to fill the cone. So W sub C as well as the dry unit weight of the sand is determined in the laboratory prior the testing. So your equipment should have a your equipment should be calibrated. So and then now that we already know the dry weight of the soil, the weight of the dry soil excavated from the hole, and then similarly for the volume of the excavated hole, we can now determine the dry unit weight. So in my previous work, I was able to witness the conduct of sand cone method. So in this first picture, you can see that the hole is dug in the compacted soil. So you can see the base plate and then the hole is being dug. And then this is the soil excavated from the hole. And then the cone, the jar, and the sand is weighed prior putting this in top of the metal plate. And then this one, so next is you have to weigh the soil excavated from the hole. And then, so that is just the weighing of the cone, the jar, and the sand with known dry unit weight and with known weight to fill the cone. And then the sand inside the jar is allowed to fill the excavated hole as well as the cone at the top. So using this valve here side. So once the hole and the cone is filled with sand, you can now remove the jar and the cone as well as the remaining sand in the jar. So as for the rubber balloon method, this is similar to that for the sand cone, but the volume of the hole can be determined by using a rubber balloon attached to a graduated cylinder. So in this setup, you can now directly determine the volume of the hole. So for the nuclear method, this uses a device. So it uses a radioactive isotope source which gives off gamma rays that radiate back to the meters detector. So according to Braham-Das, the dense soil absorbs more radiation than loose soil. So the instrument measures the weight of the soil per unit volume and the weight of water present in the unit volume of soil. Then the dry unit weight of compacted soil can be determined. So in the LMS, I have included videos in which the density of the soil in the field is determined by using the sand cone method and as well as the nuclear method. So for the California bearing ratio test, so that is under ASTM 4429 or the standard test method for CBR. So take note, ASTM 4429 is for soils in place. However, for the ASTM 1883, so this is the standard test method for California bearing ratio of laboratory compacted soils. So again, the 4429 for soils in place, and then the 18834 for laboratory compacted soils. So in the AASHTO, we have the AASHTO test designation T 193-99. So this is a simple strength test that compares the bearing capacity of a material with that of a well-graded crushed stone. So it is primarily intended for, but not limited to, evaluating the strength of cohesive materials having maximum particle sizes less than 19 mm or 0.75 inches. So it involves applying a load to a small penetration piston at a rate of 1.3 mm per minute and recording the total load at penetrations ranging from 0.64 mm up to 7.62 mm. So the one that I have included, or the video I have uploaded or in the LMS, is the standard test method for California bearing ratio of soils in place. So for the example problems 1 to 5, I will be making a separate video. So if you want some further readings about our topic in soil compaction, so you can use these references. And